Hey everyone, welcome back to our channel. If you're watching our channel for the first time, I would recommend you to subscribe to our channel and watch all our videos. So here we create videos related to backend interview preparation, AI and all the latest technologies. So watch all our videos. So in this video, basically we are going to cover top 50 plus most commonly asked Java 8 interview questions. So if you watch this video till the end, you can crack any Java 8 related theoretical interview questions. If you're preparing for Java 8 coding related questions, there is a separate video I've already created that I'm attached in the description as well. Please go and check out. That has all the coding questions. Go and check out. Without further ado, let's get started.
Let us see the first question. So the question is, what are the main features introduced in Java 8? This is definitely an easy one. So let's see the features. So Lambda expressions and stream APIs mainly to push the function style coding, these are introduced. And function interfaces, basically Lambda expressions implements the function interfaces. Default and static methods in the interface are also introduced to implement the backward compatibility and to support the multiple inheritance. Optional to avoid the null pointer exceptions. And there are changes in the date and time API as well. To achieve more async and non-blocking programming, completable feature is also introduced. So these are all the main features. We'll discuss more interview questions on all these sections. Let's move to the next question. What is a stream in Java 8 and how it is different from collection? So stream basically what it does is it will help to support some aggregate operations on sequence of elements. It basically provides a functional approach to process the collection of data, and it enables operation like filtering, mapping, reducing in a declarative way. So it's more concise compared to the traditional loops. And streams are not a data structure. That's one thing you should remember because streams will not store anything. So they are just views or the pipelines of processing the data from the collection or array or any IO resource. So stream is used to process the data. It is not a data structure. It will not store anything. And it supports a lot of operations which you can apply on the data you're processing. So the key points are it supports intermediate operations, terminal operations. So streams can be sequential or parallel also. So this is about streams. So let's understand how it is different from the collection. Stream is not a data structure, so it will not store any data. So collection stores the elements. So iteration wise, collection use even for loop, for each, or iterator. So stream is basically a functional style of iteration, you can say. So collection is modifiable. You can add and remove. But in case of stream, you can't add or remove the elements once you start processing. That's another important thing you should remember. So in case of lazy evaluation, so collection anyway it is just a storage, so we can't compare. So stream supports the lazy evaluation. So unless you put the terminal condition or terminal operation, so execution will not start. So it's lazy in nature. So collection will not have anything out of the box to support parallel processing, but stream has a built-in parallel processing capabilities. So in case of collections, you can traverse any number of times. But in case of stream, it's one time you can traverse. Once the terminal condition is added, it's done. So collection is kind of an imperative style and the stream is a functional style in nature. I hope you got it. So I hope you understood what is streams and what are the difference between streams and collection. Let's move on to the next question. Let's see the next question. So what are the difference between intermediate and terminal operations in streams? So what is the difference between intermediate and terminal operations in streams? So basically, we have to understand what is intermediate operation first. So intermediate operations basically that returns new streams which let further execution, further operations, and they are not executed immediately. So execution happens only when terminal operation is called. So like basically the usage of intermediate operation is for transformation, filtering, mapping, etc. So you can see the examples also filter, map, testing, sorted are all examples for the intermediate operation. So what is terminal operation? So terminal operation is basically that produces the result or a side effect, or it will basically terminate the stream. So all the terminal operations are executed when terminal operation is called. Okay, like collect, reduce, consume, for each, count. All these are examples for the terminal operation. I hope you got it. So terminal operation is when the result you will see. Before you call the terminal operation, intermediate will not start executing. So this you should remember clearly. So some of the differences as we already discussed. So intermediate operation creates new streams. Terminal is an end. So we'll get the result there. So intermediate is lazy in nature because once you add the terminal operation only it will start the execution. So intermediate we can have a chaining. So we can have map, filter, etc. chaining. But terminal operation is once you add the terminal operation, you can't further process on that. Okay. So examples you already seen like filter, map, sorted, testing are example for intermediate. For each, collect, reduce, count as example for terminal operation. I hope it's very clear to you. Let's move on to the next question. Let's move on to the next question. So the question is, what are the difference between reduce, collect, and for each? So these are all the three operations which is supported as part of the streams. So reduce is basically reduce the stream to a single value using an accumulator function. So I'll repeat, reduce is used to convert the stream to a single value using an accumulator function which we specified inside the reduce. So it combines elements into one. That is either you can use sum, product, max, min, concatenation, everything. So it returns an optional value. Okay. So here you can see an example. I have these numbers, I'm streaming it and I'm reducing it to this. So basically it's kind of a summation I'm doing with reduce. So it reduces a stream to single value. Okay. Let's understand about collect. Collect is basically it collects the element into mutatable container. So it can be list, it can be set, it can be map. So it performs an aggregation using collectors. So it transforms the stream into collection or custom result. So you can see the example here. We have taken a list of strings. We are filtering strings which are length greater than 3 and we are collecting to a list. So we when you want to collect the element to mutable container, it can be list, it can be set, it can be map. You can go with collect. So for each, it's a pretty straightforward one. It's basically to perform printing operation, logging operation, and some kind of update also you can do with the for each. So it returns nothing. It consumes the stream and returns void. In case of collect, it returns a container. So example is pretty clear here. You can see name, stream for each we are doing. So I'll just show you an example for reduce and collect so that you'll understand the result. Let's go to the example. So here in this example, right, we are using collectors. So collector, as I said, it is used to collect the result to a mutable container. It can be list, it can be set, it can be map. Here we are collecting into map. So it will split the string into characters like H, E, L, L, O, etc. So we are checking blank because space we don't need. After that, we are collecting each character and we are having a counter like what is the frequency of the collector. So what is the frequency of each character we are counting. So if I run right, you can see character and its count is printed. So this is an example of collect. Let's say we want to use reduce. Here you can see we are using reduced, pretty straightforward. What we are doing is we are taking these numbers, we are limiting to two. We'll take only first two numbers and we are performing reduce operation. So let's say you want to sum all, then you can just comment this and when you run it, you will get sum for all the numbers. So that's it. Reduce is to reduce a stream into single value. using some accumulation operation. I hope you got it. So at high level, differences are this. Reduce is to reduce the stream into single value. Collect the stream into container collection. For each is to print, log, etc. Return types, reduce is basically single value return. It's an optional type. Collect is collection. For each is void. And use case wise, if you see for some minimum, maximum string incarnation, we can go for reduce. Collect, we know already. For each also we have an idea. Functional style, like all are function style. Only for each has some side effects, like you can perform some operation on it. So this is the difference between reduce, collect, and for each. I hope it's very clear to you. Let's move to the next question. Let's move to the next question. So the question is, when would you use parallel stream versus stream? So parallel stream is useful when dataset is large, when you're performing CPU intensive operations, and operations on elements are independent. So like operation of one should not influence another, and order of the result should not matter. So these are all the key things to use the parallel streams. Stream, if it is a very small data set and if it is more IO bound and when we need strict ordering, so when we have overhead of splitting, merging, so when we have such things, stream is better. So parallel stream for large data sets, CPU intensive operations, and operations of elements are independent. Let's say operation of one element if it is not prerequisite to another one, such kind of things. So a little more detailed differences. Execution wise, stream is a sequential one. Parallel stream is basically splits the work into multiple threads using fork join pool. This you should remember clearly. So execution wise, stream is basically sequential in nature, and parallel stream basically splits the work across multiple threads using fork join. And use case wise, small data sets, parallel streams for large data sets, CPU intensive operation. Threading wise, stream uses main thread, parallel stream uses available processor threads. And performance wise, it is lower and usually faster for smaller tasks. There will be overhead in case of parallel streams, and it is faster compared to the streams for larger datasets. And streams preserves the order, parallel streams will not preserve the order. So these are all the differences. I hope you understood when to use stream, when to use parallel streams, what are the difference. Let's move on to the next question. Let's move on to the next question. So the question is, what are the difference between map and flat map? This is also one of the very important question. So maybe we'll see an example first. After that, we'll come back to this to understand the difference better. So here you can see I have taken list of strings, okay, and I'm using map operation in the beginning. So I'm taking list of strings and calculating length of the each of the word, and I'm converting that into list. So basically taking A and converting into some other format. Okay. But here in the second example, right, I have list of list. What I'm doing is I'm streaming this list of list using flatMap. So here if you see, right, output of this is a stream of list. So it will do a flat mapping. So it will generate stream of integers and that is converted to list. So basically what is happening is, so here in the case of mapping, we are converting A to R or A to B. So one format to another. In case of flat map, we are basically flattening the structure. So we had list of list. Now we are converting that into a list. So that is first example. Basically, I have two strings here with space separated. So I have hello world and Java streams here as a list of string. So what I'm doing here is I have started traversing this sentences dot stream and I'm using map. So here I'm splitting the sentence using space. So what happens? Split will generate a string array of type stream because map will output stream. So it will output stream. So stream of string of array is outputted. So here we are running for each. String we got it. While printing we are using arrays to string because otherwise it will print in a class address manner. It will not be readable. So that's why we are converting the string to array string. So what happens is, so here in this example, what will happen is this hello and word is split and comma is inserted when we do this conversion and we are printing. So in one array we'll have hello comma word. In another array we'll have in another array we'll have Java comma streams. So here we are doing a flattening. So we are taking the sentence and we are splitting here with space. So output of this is basically a stream of strings. So and we are doing a to list. So which will print hello word Java streams in same list with comma separated. So here there will be two entries in a list. Here there will be only one entry in a list. Let's see the output. So first one, as I already told, right, it was taking string and getting length of all the strings. Second one, it is flattening the structure to 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this one, here you can see there are two entries. Hello world is part of one entry in a list, and Java streams is part of the second index. So in case of flatMap, what is happening is it has created hello comma word comma Java comma streams. Like this is the zero, first, second, and third index. So it's completely flattened the structure. So I hope you understood where you will use map and where you will use flat map. I hope you understood high level difference between them. So let's see the detailed answer. So difference between flat map and map. Map is to transform each element into exactly one element, which we saw already. Flat map is basically it is used for flattening purpose. So output of the map is stream and output of the flat map is stream of flattened elements. Use case wise, it is flat map is one to many kind of a thing, or it can do a flattening of many to one also. So in case of map, it is one to one. So flat map is mainly useful for nested collection and return type, as we discussed. Map is returning stream and flat map is returning stream of flattened structures. So I hope you understood the difference. Let's move on to the next question.
Let's move on to the next question. So the question is, when would you use parallel stream versus stream? So parallel stream is useful when dataset is large, when you're performing CPU intensive operations, and operations on elements are independent. So like operation of one should not influence another, and order of the result should not matter. So these are all the key things to use the parallel streams. Stream, if it is a very small data set and if it is more IO bound and when we need strict ordering, so when we have overhead of splitting, merging, so when we have such things, stream is better. So parallel stream for large data sets, CPU intensive operations, and operations of elements are independent. Let's say operation of one element if it is not prerequisite to another one, such kind of things. So a little more detailed differences. Execution wise, stream is a sequential one. Parallel stream is basically splits the work into multiple threads using fork join pool. This you should remember clearly. So execution wise, stream is basically sequential in nature and parallel stream basically splits the work across multiple threads using fork join. And use case wise, small data sets, parallel streams for large data sets, CPU intensive operation. Threading wise, stream uses main thread, parallel stream uses available processor threads. And performance wise, it is lower and usually faster for smaller tasks. There will be overhead in case of parallel streams, and it is faster compared to the streams for larger datasets. And streams preserves the order, parallel streams will not preserve the order. So these are all the differences. I hope you understood when to use stream, when to use parallel streams, what are the difference. Let's move on to the next question. Let's move on to the next question.
So the question is, what are the advantages of Java streams? So many candidates will not give the correct answer. Let's see the answer. So it's concise and readable. Basically, it will support this declarative style of programming, and it reduces a lot of boilerplate compared to traditional loops, making code more readable and easier to understand. Okay, and it improves the performance with lazy evaluation, as we already discussed. Only if the terminal operation is attached, it will start execution. So it will not start the computation unless you add the terminal operation. So that is very much important when you are processing the larger datasets and complex pipelines. It supports even parallel processing also. As we know, Stream has parallel stream. It enables efficient utilization of the multi-core processor, which leads to significant performance improvement as well. And it supports functional style of coding with all this function interfaces like predicate, function, consumer, etc., which is more cleaner, modular, and often more testable as well. So streams operations can be chained together. Like output of one operation, you can add it to another. So a kind of chain you can create. So which helps to create reusable code, more clear code. So immutability aspect. So basically streams typically operate on a data without modifying the original resource. That is one of the important things you should remember. So streams will not modify the original collection or array. So it supports immutability. So it reduces the unintended side effects. So code is more predictable and robust in nature. So this is another advantage. This is very detailed answer. Okay, so many will not be aware of all these things. So I always strongly recommend if you say all these things which conveys to interviewer. Okay, so this person knows everything about the streams. So let's move on to the next question. Let's move on to the next question. So the question is, what are stateless versus stateful intermediate operations in streams? I think you may not see this question in majority of the tutorials. This is one of the interesting question also. So that's why I always say like watch my video till the end so to get the complete benefit out of it. So the question which I'm covering is asked frequently in the most of the interviews and they're tricky in nature in some of the cases. So I'm giving a detailed answer as well so that you should get benefit out of it. So watch the video till then. That's first thing. Second thing is I'm sharing the link to all the interview preparation material. So you can go and check out that. So the link will be in the description. So let's see the answer for this. What are the stateless and stateful intermediate operations? So intermediate operations, you are aware, the operation which transforms or produces the another stream. Okay, they are not the terminal or the end operation. So there can be stateless and stateful. So what is this stateless and stateful? So first we understand the stateless operation. So each element is processed independent of the other. So it will not retain the state across elements. So it's just faster and scalable in nature. Okay, so parallel processing. So you can see map, peak, filter. These are not dependent. Like execution of one element will not be dependent on another element. So they are stateless in nature. So let's see the stateful examples. So this is stateful intermediate operation. Okay, here the execution of one element depends on the other elements. So that's why these are stored temporarily and it will impact the performance, especially in case of parallel streams. Okay, so here you can see, so here examples are distinct. So distinct means element, if you have to find distinctness, you have to compare with other elements. You should know the state of other elements. So sorted is also same thing, limit, skip, etc. So these are all examples for stateful intermediate operations. So key differences are dependency on other element. In case of stateless, it will not depend on other element execution. Stateful, it will. So stateless, no extra memory. Stateful requires an extra memory, buffer, etc. So performance-wise, stateless is faster. Stateful is slower. Examples are given here. I just want to show a simple execution of an example. After that, we'll move on to the next question. Here you can see it's a mix of stateful and stateless example. The first one, this is basically stateless in nature. The second one is a stateful in nature. So I'll just show you. And so here what is happening is you can see first one is printing 4 and 8. Second one is printing 1, 2, 3, 4, 5. So operation wise, if I have to tell, I should have added a delimiter to separate the result. I hope you can understand. So here you can see we are mapping. We are taking these elements and finding all the elements which are even in nature and multiplying that with 2 and printing the result. And here it is sorting in nature. So I can't process 5 simply without knowing other elements. So I hope you understood. But this is independent. Each element execution is independent of other. So this is the difference between stateless and stateful operations in streams. I hope it's very clear to you. Let's move on to the next question. So the question is, can we configure thread count in parallel streams? So this is one of the question I've seen majority of the candidates will tell wrong answer. They will not be aware because normally parallel stream is not used that often. Even though they have used, they will not be aware what is the underlying threads it uses. So this is one of the tricky question I would say. So answer is yes, thread count used by the Java parallel streams can be configured. Okay. So another question you can get is what is the default thread count which is used by the parallel streams also. So both of that will be answered in this question. By default, parallel stream utilizes common for join pool. So the count is equals to, you can see the available processor minus one, leaving one processor for calling thread. Okay. But you can configure this by setting this property like common parallelism system property. You can set to desired value to change this count. Okay. So this will basically used throughout the application. And second thing is you can have your own custom for join pool to have more fine-grained control. You can create your own for join pool and you can submit the parallel stream. So I hope you got it. So it is possible to configure the thread count in parallel streams. The steps are defined here. But if you want to use the default one, that is basically its total number of available processor minus one. So I hope you got it. This is one of the tricky question, an important question also. Let's move on to the next question. Let's see the next question. So the question is, how does short circuiting works in streams? This is an interesting concept actually. Short circuiting means you don't need to execute the complete collection. So if the condition matches, you will short circuit there only. That's what a short circuiting operation means. So you can see stream pipeline can be terminated early without processing all the elements once the result is determined. So it works well due to lazy evaluation of intermediate operations. And it's like AND and OR operation, which is used in our coding. So types of short circuiting we have to understand. One is short circuiting intermediate operation. So here you can see we are limiting. So I just need only two elements. So after that, I'll not process it. So I want to skip some elements. So I want to skip first n elements. Only I have to process the remaining ones. So something like that. So you have to basically short circuit. You will not execute all the things. So in case of terminal operations also you can short circuit. So you can use any match, all match, none match, find first, find any, all these things.
So
So
as
as
soon
soon
as
as
the
the
result
result
matches,
matches,
the
the
execution
execution
stops.
stops.
So
So
why
why
is short
short
circuiting
circuiting
matters?
matters?
This
This
is
is
one
one
of
of
the
the
important
important
thing.
thing.
Because
Because
in
in
the
the
performance
performance
optimization,
optimization,
you
you
don't
don't
need
need
to
to
process
process
unnecessary.
unnecessary.
So
So
you
you
can
can
just
just
imagine
imagine
you
you
are
are
processing
processing
a
a
large
large
data
data
set.
set.
So
So
if
if
you
you
don't
don't
have
have
short
short
circuit,
circuit,
what
what
happens
happens
is
is
you
you
have
have
to
to
execute
execute
all
all
the
the
elements.
elements.
So
So
it
it
is
is
memory
memory
efficient
efficient
also
also
in
in
case
case
of
of
short
short
circuit.
circuit.
You
You
don't
don't
need
need
a
a
lot
lot
of
of
memory
memory
to
to
store
store
the
the
details.
details.
So
So
it's
it's
very
very
useful
useful
in
in
case
case
of,
of,
for
for
example,
example,
in finance
infinite
streams
streams
or
or
a
a
large
large
data
data
streams.
streams.
So
So
I
I
hope
hope
you
you
understood.
understood.
I'll
I'll
just
just
show
show
you a
you a
simple
simple
example
example
and
and
we'll
we'll
move
move
on
on
to
to
the
the
next
next
question.
question.
So
So
here
here
I
I
have
have
taken
taken
two
two
examples.
examples.
So
So
here
here
This
This
is
is
an
an
example
example
for
for
the
the
intermediate
intermediate
short
short
circuiting.
circuiting.
So
So
this
this
is
is
a
a
terminal
terminal
operation
operation
short
short
circuiting.
circuiting. So I'll just run first. So first one you can see what we are doing is we are just printing the first three numbers. After that we are short circuiting. So second operation we just have to find is there any even number in a given stream of elements. If it is there, we just have to short circuit. So we don't need to process all the numbers. I hope you understood. So that is the difference here. So here we have only one even number, but let's say there are more even numbers. You don't need to consider all. As soon as you match one even number, you can short circuit. So I hope you understood the difference. It will provide better performance and memory optimization. I hope you got it. Let's move to the next question. Let's move to the next question. The question is, can you modify a collection while iterating through a stream? So, can you modify a collection while iterating through a stream? So, the thing is, the recommendation is you should not modify because streams are designed for transformation, not for the mutation operation. So especially if you want to add or remove an element to the original source, right? That is not recommended. It can lead to concurrent modification exception or any other unexpected behavior. So it's not recommended to try that as well. So because most of the collections uses fail fast iterators, even Stream will also use that. So if some structural changes happens to a collection, then it will lead to concurrent modification exception. So the answer is, can you modify means no, you should not do it. It's not recommended because you may end up with some unexpected behavior. I hope it's very clear to you. Let's move on to the next question. Let us move on to the next question. Can Stream APIs improve performance? Why or why not? So yes, but not always. This is the best answer actually you can give. Because Stream APIs will not always improve the performance. This you should have a proper clarity. Because many of the people think that if they use Stream means it is faster. So primary goal of Stream is like readability, declarative programming. Speed is like not the first priority. Okay. Performance improvement, it completely depends on the data set size, operation type you're performing, and the parallelization. Three aspects are important in that. So when streams can improve the performance, let's understand. So parallelism, like streams make it trivial to spread the workload across multiple CPU cores. Let's say if you use parallel streams, it will split the work into multiple streams and run using multiple cores of the CPU, which will basically faster in nature. So it is lazy evaluation in nature. So basically, once you add the terminal operation, then only the intermediate operations will be executed. So it will avoid the unnecessary computations. Okay. So when streams might be slower. So if you're playing with a small collection, so there it's like overhead of creating streams, lambdas, pipeline management is higher compared to the simple loops. Sometimes like too many intermediate operations can become overhead also. So parallelism misuse. So dot parallel streams can hurt performance if dataset is small. Operations are IO bound. If it is IO bound, even if you use parallel stream also, what is the problem is threads can't execute. It has to wait for the IO to respond. Only if it is CPU bound operation, parallel streams are faster. So task is not easily parallelizable sometimes. In those cases, parallel streams will also be not useful. So I hope you got it. Let's see an example also. So as I always say in my videos, I'll try to give more practical experiences so that it will register in your mind. It will be useful for your day-to-day coding as well. So let's see the example. So here what I've done is I've created a list with 100 million integers. So we are basically performing the addition operation using three different ways. One is using sequential stream. You can see I've taken the list, I'm streaming it, and I'm performing a sum operation. Same thing I'm doing with parallel streams. And the last option I'm doing with a simple for each loop. So every number I'm taking, I'm summing. So in each of these process, I'm calculating the total time it is taking in nanoseconds. Okay. So let me run it. So it will take few seconds definitely. So you can see the parallel stream took less time compared to rest of the two flows. Even here actually for loop did better job compared to sequential stream. So maybe I'll just run it and show you one more time. So as I was telling, so parallel streams are better when you're performing uh, operation on larger data set, and it should be parallelizable. So, and it should be kind of a stateless. If there is a stateful operation, then it is not efficient. So I hope you understood. Streams are not always performant. Let's say if I change this number to, for example, 1000 or 100 maybe, and I'll just run it. So here you can see for loop did a better job. Parallel stream did a worse job. Sequential stream did a little better job compared to parallel stream. So as I already told, streams not always be performant. This you should be very clear, because many of the people who are using the streams for long also they will not be aware of this. So that's why, as I always say, I'll go to the depth so that you can understand better. So I always recommend watch my videos till then so that you will get more benefit out of it. And if you are preparing for Java 8 coding questions, I have a separate playlist as well. So I'm sharing that link. Please go and check it out. It has an exhaustive list of Java streams coding questions. So if you solve that, you can crack any Java 8 stream related questions efficiently. I'm sharing a link at the description, and I'll show you the link at the top as well. So please go and check it out if you want to prepare on the Java streams coding questions. Let's move to the next question. Let's see the next question. Can we throw checked exceptions inside the stream operations or stream pipelines? Even though some of you might have worked on streams for longer duration, then also you may think twice. Is it possible or not? So let's see the answer. So you can't directly throw the checked exception from the stream pipeline. It is not possible. It will give you compile time error, because stream operations are designed to work with unchecked exceptions or runtime exceptions. So checked exceptions require explicit handling, which does not fit neatly into the function interfaces. So that's why it is not recommended to throw. If you throw a checked exception, you will get a compile time error. So what is a workaround? So one way is you can use some helper method to wrap that exception, or you can basically use runtime exceptions, and in that you can pass the compile time exception object. So I'll show you the example in a while, but we can go through the key points. Checked exceptions are not allowed inside the stream lambda directly. So we should catch and wrap them as an unchecked exception if you want to throw, or custom function interface to handle the checked exception elegantly. So let us see the example to understand it better. So here, right, if you see, we are processing a file, and when we get an exception, this IO exception is a checked exception. But let's say I want to throw this exception. So let's say if I just remove this and try to throw, right? It is not possible. It will say again add a try catch to handle this. So let's say your requirement is to throw this exception somehow. Then one of the option is use the runtime exception and pass this compile time exception or checked exception object. This is one way to do it. So this is another way to handle it. So what we are doing here is, so we are processing the same file subject using streams, and we are calling the map like the way we did here. But instead of having a try catch here, we basically used this wrap method. Wrap is basically taking this method as an argument. So this is nothing but a lambda. We are sending it to this wrap method. And here we are basically capturing that exception and throwing the runtime exception. So it's the same as previous example, but little more modular and easier to read. So same operation we are performing, but we are calling this wrap method and doing it. Another thing is, since it's a functional interface, so we had to use like throws exception here to handle that. Otherwise, we'll get an error. So simple answer is you can't throw the checked exception. So you have to wrap that checked exception object inside the unchecked exception and throw it. So that's the only way. I hope you understood. Let's move to the next question. Let us see the next question. The question is, what are function interfaces? Can you create your own? So let's see the answer. Function interface is an interface and it can contain only one abstract method. And it can have any number of default and static methods. So you should remember clearly, function interface can contain only one abstract method. Exactly one. Because many candidates gets confused in the interview when an interviewer asks, uh, can there be more than one abstract method? Candidates get confused. Or sometimes what will happen is when interviewer asks, can it contain default and static methods? There also many will confuse. So function interface means it will contain only one abstract method because Lambda can implement function interface and it should contain only one abstract method. So it can contain any number of default and static methods that will not influence anything. But if you add more than one abstract method, right, it will not be called as function interface. So it can't be implemented by Lambda expression if an interface contains more than one abstract methods. I hope it's very clear. So these are all the examples. This is another thing, even though we have used these function interface in day-to-day work, we will not remember the examples. So runnable, callable, comparator, predicate, all these are the examples for the function interface. So let's see the example also, how to create function interface. This is an example. This is a function interface and it is containing only one abstract method and a default and static method. So this function interface annotation, it's an optional one. What it does is, let's say if you try to add one more abstract method, say new message, it will throw an error. So if you see, right, it is saying it's a compilation error. Multiple non-overriding abstract methods found in an interface. So function interface can contain only one abstract method. So that is violating. That's why it's throwing an error. So we just have to have only one abstract method, any number of default methods. Let's say if I just clone this and if I say method one, this works fine. So there is no problem with it. So any number of default and static methods. And this is an example. So here we are instantiating this function interface using Lambda and that we are using it. So I'm not going to go in depth on these things because if you want a depth session on Lambda, let me know. I'll create one more. So yeah, this is the function interface example. I hope it's very clear to you. Let's move to the next question. So let us see the next question. So the question is, what are default methods in interface? Why were they introduced? So what are default methods and interfaces and why were they introduced? So let's see the answer. Default method is a method which is inside the interface that has concrete implementation using default keyword. So basically default method will have a concrete implementation. Okay. And the classes implementing this interfaces automatically get this functionality. So I'll repeat, default method is basically a concrete method which is inside the interface. So what was happening was before Java 8, interface was containing only abstract methods. From Java 8 onwards, what has happened is interface can contain default and static methods. So default will have an implementation. So the class which is implementing the interface will get the default method implementation as well. So this is an example here. You can see we have a default method. So this is how it looks like. It should be attached with a default keyword. I hope it's very clear to you. We can see a small working example as well to understand better. So this is an example. We have vehicle interface and it has drive as an abstract class and we have the default method that is called start. So this car is implementing this vehicle and we have this drive as an abstract, so we have to implement. But start as a default method, we don't need to explicitly implement. If you just want to use the interface behavior, we can use as it is without implementing it. So here you can see we are creating a new car and we are calling start method first, and after that we are calling drive method as well. So start is a default method. So let us run and check the result once. So here you can see, drive method is called here. It's printing driving car, and start method, which is a default method, it's printing starting vehicle. So I hope it's very clear to you. This is how default method can be implemented. And why were default methods are introduced? This is very much important because many of the times, right, we will know the concept but not fully. So when an interviewer asks why it is introduced, many candidates get confused. So basically, main use case is to provide the backward compatibility. Means before Java 8, what was happening was interface was containing only abstract methods. So if a class is implementing an interface, means it has to override all the abstract methods. But Java 8 onwards, this default method is introduced because let's say if Java wanted to change some interface which is already existing and which is used by multiple classes. So it was not possible before Java 8 because if they introduce any new method in the interface, all the implementing classes should override it. So it was breaking all the things. So that's why what they did is they introduced a default method with an implementation. Because of that, it was not creating any problem for the existing classes which are implementing the interfaces. So I'll just repeat. So before Java 8, what was happening was interface was containing only abstract methods. So all the classes which were implementing it should override it. But let's say you want to add new functionality to an existing interface. So only option was introducing the abstract method. So which was basically breaking all the classes because class has to override this functionality. So to handle that, what Java did is it came up with a default method. So default method will have an implementation at the interface itself. So all the classes which are inheriting, right? So they can inherit that behavior. If they really want, they can override or else they can inherit. So this led the Java to introduce new functionality in the existing interface without breaking. So this is the reason for introducing default methods. So this is heavily used in collections, heavily used in streams. So instead of forcing old collection implementation to rewrite the methods, default methods allow smooth adoption. I hope it's very clear to you. So with the default method, interfaces can evolve without breaking the old implementation. Default method is helping to get the multiple inheritance behavior as well, and it has some side effects also. We'll get to know in the future questions. I hope it's very clear to you. So I hope you understood what are default methods, why they are introduced, and how to create your own default method. So let's move on to next question. Let's see the next question. So the question is, can interfaces have static methods in Java 8? Why this is useful? So we know it is possible. Starting from Java 8, interfaces can contain static method with implementation. Why this is useful is this will act as a utility or helper method. So we often create utility classes to basically handle some of the operations. So what Java did is it introduced the static method which is inside the interface so that let's say you have an interfaces related to some collection operation. You need some helper methods. So you don't need to create your own. You can have a static method inside the interface itself. It can be used as a helper method. So if you see, right, comparator interface has static method like comparator.comparing to compare the inputs. With this, what is happening is the comparing utilities inside the static method only. So let's say you are creating your own version of some code. There also you want to create an utility method, right? You can have it in the interface itself. So it's more handy and those who are using your interface will get that out of the box. So that's one of the biggest advantage of the static method. So no one will go this depth, okay? As I always tell in my videos, So this basically is done with a lot of research and by studying the documentation. So I would always advise watch the video till the end to get the complete benefit. And I'm giving all this interview questions link as well as part of this video. So after this video, please check out that link also. So one more related advantage is basically to bundle behavior with an interface. So let's say like this will help you to basically create a cleaner APIs. So which will contain all the required helper methods also together. So it's like one bundle you will ship it. So whoever is consuming, they don't need to create any helper methods to use that. So that is the second one. It's almost like a first one only, but little bit extension. So what are the key points we have to remember? Static methods in interface cannot be inherited by implementing classes. So which means it's like the static method is at the interface level. So the inheriting classes will not have its own copy. So there will be only one copy of the static methods at the interface that is being used by all the implementing classes. So I hope it's very clear. Static methods in interface cannot be inherited. Means like the child class or the implementing class can't override the static method. Static method is either bound to a class if it is inside a class, or if it is inside the interface here in this case, it is bound to that interface. So it can't be inherited. So you must call them using interface name. Because if the interviewer asks you, what is the difference between static and default methods? Both are having implementation. Why we need both? So you may get this question. So main thing is static method cannot be inherited and static method will be called using an interface name. So in case of default method, an implementing class can override the default method behavior. I hope it's very clear to you. And another thing is this static and default method can be in normal interfaces also. That's one thing you should remember. It's not just with the function interfaces, it can be with the any interfaces. So let's see an example for static method, and after that we'll move on to the next question. I have created an interface and a default method and a static method. So here the static method demo is implementing that. Okay. As I was telling earlier, static method here it is bound to an interface. So you can't call this static method directly from this class because the static method is bound to this interface. So you can use interface name dot the method name to call it. Okay. And default method, as I was telling, a class can inherit default method. Class cannot inherit static method. That's why to call the default method, you can use object of this class and you can call it. So
So
each
each
object
object
will
will
have
have
its
its
own
own
copy
copy
of
of
the
the
default
default
method
method
and
and
they
they
can
can
override.
override.
But
But
static
static
method
method
is
is
common
common
for
for
all
all
the
the
objects
objects
which
which
is
is
implementing
implementing
the
the
interface.
interface.
I
I
hope
hope
it's
it's
very
very
clear
clear
to
to
you
you
because
because
main
main
use
use
case
case
of
of
the
the
static
static
method
method
is
is
to
to
act
act
as a
as a
helper
helper
method.
method.
So
So
you
you
don't
don't
need to
need to
have
have
a
a
copy
copy
in
in
every
every
object
object
which
which
is
is
implementing
implementing
this
this
interface.
interface.
So
So
let's
let's
move on
move
to
to
the
the
next
next
question.
question.
Next question is, can functional interface extend another interface? So this is an interesting question. Okay, normally we will not think about this because we'll not use it in a day-to-day coding. So let's try to understand this with an example. The question is, can function interface extend the another interface? It can be function interface or non-function interface also. Let's try to understand with examples. Okay, this is a variant where here the base functional interface, right? You can contain only one abstract method, which is following the function interface criteria. And the derived interface is extending the base interface. There is no additional abstract method here. This is perfectly fine because this interface is containing only one abstract method that is coming from the base interface, which is perfectly fine. No additional abstract method. It can contain default static. So this is a valid combination. I hope you understood. So if a function interface extends another function interface, if the derived interface does not contain an abstract method, then it is possible. Let's try to understand the next case. So here, right, there is already one abstract method in the base function interface. and there is one in the derived also. So here it is not possible because when this derived is extending the base, so when this derived is extending the base, what is happening is this derived is getting two abstract method, one from the parent and one is already present in this interface also. So this is an invalid combination. Let's try to explore same thing with regular interface. It's the same case holds good. Let's go to here. So let's say if it is a regular one, I'm just removing this. So if it is a regular one, then also if it just contains one abstract method, then it is perfectly allowed. In case of invalid also same thing. If I remove this, so if there is one abstract in this, and if I try to extend, and if there is already one more in the derived, then it violates. But let's say instead of this, if there is a static, say static void, and let's call it as static method just for example, and this contains maybe just a sysout static method. So this is perfectly fine because the base interface is not containing any abstract methods. Just the child interface or derived interface contains it. So which is not violating the principle. I hope you understood the different cases clearly. I'm giving examples for most of the questions because this has to be registered in your mind. Because if you just read the answers, right, many of the times you may not be able to recall. If you write and practice and understand the concept, then only you can answer well.
So the next question is, what happens if a class implements two interfaces? They both have same default method. So that is the twist. Okay. So a class is implementing two interfaces. They both have same default methods. So let's see and understand this in detail. So what happens if a class implements two interfaces and they both contains default method of same name? So this is not a regular day-to-day coding thing. Okay. We may not encounter this situation often, but in interview this can be a tricky question. But it's good to understand the concept clearly, so it will be useful for day-to-day coding also. Here C is implementing A and B, and both are having greet as a default method. So when I hover on it, right, it will clearly say inherits unrelated defaults. So it's basically compiler will not be aware which one to implement. Let's say if class was implementing A, there was no problem at all. It was directly using its default method. But it is basically implementing both. So it's getting confused what to do. So we have to implement it. We have to implement the default method here. And here we are calling a.support.greet. If you want to get the B's one, we can call B here. Or let's say we want to replace both of this with some other our own overridden thing, that also we can specify here. So here we can specify our own logic here. This is also perfectly fine. So basically, if a class is implementing two interfaces which contains same default name, then you have to override it. So that is the expectation. So let us say, so here these default methods are also containing same return types. Let's say if it was int here. Okay, I'm just returning int here. Now problem difficulty increased. So now can we apply the same overriding behavior here? No, because both of these methods containing different return types. Let's say even if I hover on it, right, and click on the implement, it will not work. Even it is implementing, it is still throwing an error. See, it's saying that it clashes with the greet method of B because B is containing int return type. So it's not possible at all. And both the return type should be same. Is it the case always? That's the next question interviewer may ask. So let's say here instead of void we had number. Okay, and we are returning number here. And same thing here, instead of int it is integer. Here let's say instead of int it was integer, then return one I'm doing. Now if I hover on it, right, and implement, it works. There is no error. Do you know why? Mainly because this integer is a subclass of number. So if I go inside here, right, you can see integer extends number. So integer is a subclass of number. So when there is a superclass and subclass combination in return type, then you can override. It's perfectly allowed. So when there are two unrelated return types, we can't override. So three cases we discussed. So first case, return types are matching, that is void. Even if it is void, integer, anything is fine. It should match. Second one, void and int combination we tried. We couldn't override. Third one, number and integer combination. Superclass and subclass combination. It worked. I hope you understood different variations of the same problem statement. So I would recommend go and practice and understand it better. Let's move on to the next question. So subclass must override the conflicting method, otherwise it results in a compilation error. So this is very clear to us. Let's move on to the next question. Let's see the next question. So the question is, what is lambda expression in Java 8 and its syntax and examples? So basically, lambda expression is kind of a short block of code that can be passed around like a data. So it's like you can pass the function to a method as an argument using lambda. Okay, so it's like Java way of bringing the functional programming features. So lambda expression in Java 8 is concise way to implement function interface. So this is the syntax, parameter and body and a connector in between. Basically, it reduces the boilerplate code. So we'll understand more with examples also. Basically reduces the boilerplate code. We'll understand this with more examples. So lambdas can only be used with function interfaces. This you should be very clear. So it should contain only one abstract method. They can make code more concise, readable, and maintainable. They can capture variables, but only those that are effectively final. So this we'll discuss in detail in the next question. So let's see the example of a lambda and we'll understand how it will create concise and more readable code. So here you can see an example. First, I've taken a runnable interface. Previously, before Java 8, we were using anonymous class to implement. This is one of the example. So this is one of the way, but there are other ways to implement the runnable. So with anonymous class, you had to do like this. You have to create new and internally you had to override that method. And Java 8 onwards with Lambda expression, what is happening is this whole thing, I think up to till you can say this is just replaced with this and it is having this implementation here. That's it. So you can see how concise it is. So a lot of boilerplate code is avoided. Okay. And you can take an example of comparator as well. So previously it was comparator and new comparator, you had to do it and a lot of things. Now it's just one line. It is taking two arguments A and B, and this is how it is implementing. That's it. You can see how concise it is, and a lot of boilerplate code is avoided. So same, some more examples I've taken here. Here you can see we have to print all the names. Just name and an arrow, and you can have this out. So same thing here, we are filtering and printing. So these are all the advantage. So because of this, the code is more concise and a lot of boilerplate is avoided, and we are moving towards more functional style of coding. I hope you got it. So let's move on to the next question.
Let's move on to the next question. So the question is, can we use break or continue inside a lambda expression? So this is an interesting one because normally I think we have not explored this. So even though we have used lambda, I don't think we have explored whether we can use break or continue. So let's see the answer. So basically, inside the Lambda, you can't use break and continue because these are all called as control flow statements. We can't use it. It will be used normally inside the loops and switches. So if you need it, then you have to restructure the logic. You can't use the Lambda. But there is a small alternative. Let's say if you need continue, instead you can use return statement. So I have written a small example to explain that. Here, what I've done is I've written a small example. If, like for example, n equals to 3, I'm returning. So normally continue is used in this use cases only. So instead of that, you can use a return if you need that kind of a behavior. That's one example, or that is one way you can achieve that. But you can't use any break or anything. So you can't like add continue. Like for example, here I'll add continue, then I'll get an exception. So we can't do it. And at the same time, I can't break also. So that's also not allowed. I hope you got it. So basically all the control statements like break, continue, we can't do it. So just to mimic the continue, we can use return. That's one option available. I hope it's very clear to you. Let's move to the next question. So basically it's not allowed. We have to restructure our logic. Let's see the next question.
Let us see the next question. So the question is, how are lambda expressions compiled internally? So this is not regularly asked, but this is one of the interesting question because we know like lambda expression will replace some of the anonymous class implementation, not all. We'll understand more also in the follow-up question. But let's say if somebody asks you how lambda expression is compiled internally, then you should know this very well. So unlike anonymous class, right, lambda expressions are not compiled into separate class. Because in case of anonymous class, even though we have not returned the class in the example I showed, but when it compiles, it will compile to separate class. So it will create a lot of bytecodes. But with lambda, what is happening is, so what it happens is, what invoke dynamic do is at runtime, it will decide what is the best way to basically execute this lambda expression. So invoke dynamic can be used at, for example, string manipulation as well. So when you do string concatenation, so invoke dynamic is used at the runtime to decide what is the best strategy to concatenate the strings. So there are a lot of other use cases as well. So here in this lambda expression also invoke dynamic is used. So first you have to understand it will not compile into separate class like anonymous in a class. And let's understand the step-by-step breakdown how lambda expression is compiled. So no extra class created. That's very clear. You can see with anonymous class, it was basically creating an extra class means extra bytecode. So that's an overhead which is avoided using lambda expressions. And compiler generates a private static synthetic method. So we don't need to go in depth on it, but this is how it is. Like I've taken an example. This is basically converted into a synthetic method like this. The next step, this invoke dynamic and lambda meta factory is used to create the instance of the function interface, which is pointing to synthetic method. That's it. So these are all little depth. You don't need to know everything actually. What you have to do is it will not create a new class and it uses this invoke dynamic method to take care of handling the function interface efficient. So what you have to remember is one is it will not create a new class. So first thing you should remember is lambda expressions will not be converted into a new class when the compilation happens. So it will be converted to synthetic method. So it uses invoke dynamic and lambda meta factory to basically execute it. So that's a high level thing. So not very regularly asked, but a good to know question. Let's move to the next question. Let's see the next question. So the question is, what are the difference between anonymous in a class and lambda expressions? So this is one of the interesting question. So anonymous in a class, it is bit more verbose in nature. We have seen the example. Lambda is more concise. It avoids a lot of boilerplate codes. So anonymous in a class, it will compile into new class, which we discussed already, but Lambda will not. Anonymous in a class, right? It can implement any interface. but lambda is meant for only function interface. So if an interface containing more than one abstract methods, then anonymous class we can use it. So here, this pointer, the this keyword, right? So this inside the anonymous inner class refers to the instance of the anonymous inner class itself. But here, this refers to the class which is enclosing it. So let's say I'm having lambda inside a class. If I use this dot something inside the lambda expression, right, which will point to the enclosing class. In case of anonymous inner class, it is basically pointing to the instance of the anonymous inner class itself. Okay. And variable capture. So basically, anonymous inner class can have, so anonymous inner class captures only final variable. So here variables which is inside the anonymous inner class should be final, but in case of lambda it can be effective final also. We'll understand what is effectively final in the next set of questions. And in terms of performance, anonymous inner class is slightly heavier and requires more memory compared to the lambda, which is lighter, faster, and optimized at runtime. So use cases, let's say there are complex classes and multiple methods, right? Then anonymous inner class is the best thing. So this is for very short one, a single method behavior like function interface is useful. So I hope you understand the difference between anonymous inner class and lambda expression. This is one of the important question also. So if you still have open questions, pause this video, just go through the differences in detail. So if you have some questions, you can ask me in the chat as well. Let's move on to the next question. So the next question is, can we use this and super keywords inside the lambda expressions? See the answer. So in lambda expression, this keyword refers to the enclosing class. I'll show you an example also. So it will not refer to anything else. And this is different from anonymous inner class, as I already told in my previous question, because in anonymous inner class implementation, it refers to the anonymous inner class instance itself. So in case of super keyword, so you cannot directly call super inside a lambda because lambda does not define a new scope. So can we call super inside the lambda expression? So first you should understand what super does. Super is basically to call the parent class. So inside the lambda expression, you can't call the super simply. You can do it only inside a subclass to call the superclass method. That is possible. So simply you can't use super keyword inside the lambda expression. So let's try to understand with examples. So here in this example, you can clearly see, right? I'm using super keyword. I'll just add a line to make it more readable. So here, this is basically extending the parent class. So I can call the parent class green method inside the lambda expression. It is perfectly allowed. So I hope you understood. So we can call the parent class methods. We can't simply use super unnecessarily. So that holds good with lambda as well. So in case of this pointer, as I was telling, this is basically referring to this particular class. So I'm using, I'll maybe run and show you the result. So this pointer is pointing to the enclosing class of the lambda expression. But in case of anonymous inner class, it will refer to the instance of the anonymous inner class itself. That is the difference. So I hope you understood. Let's move to the next question. Let us move on to the next question. So the question is, what is the difference between lambda expressions and method references? So I'll show you an example to understand more about what is lambda expression, what is method reference. After that, we'll come back and see the differences in detail. Let's move on to the example. So here I have created an example. Like here, if you see, I'm using lambda. Here I'm using method reference to achieve the same behavior. So I just want to print this names list. First, what I'm doing is I'm doing a for each on this names list and I'm using lambda to print it. I'm taking every name and calling sysout to print it. In case of method reference, what is happening is this whole thing is replaced with system out println directly. So This is the major thing. So compared to Lambda, the method reference is a bit more concise, but we can't use method reference in all the places. Let's say there are multiple lines of code here. For example, here instead of one line, there are multiple lines of code. So if I add, for example, another line of code, sorry. So if I add another line of code here, so here I've added another line of code. So now I'm just printing example. This can't be replaced with lambda expression. So this can't be replaced with method reference because if there is only one action we are performing, method reference can replace the lambda expression. So let's say if I do undo of this, right? If I go back to the previous state, now you can see ID is also showing replace this with the lambda expression. But when I added multiple lines, it was not showing any such because it was not possible to replace with a method reference. Only if there is one line of implementation, then method reference is a right fit. If you are performing multiple actions, then you can't replace with a method reference. I hope it's very clear to you. Let's see the difference in detail. So now the difference here I've clearly explained. Lambda expression, it's basically kind of an anonymous function which is passed as an argument to the method. But method reference is referring to some existing method. So here that println whatever we saw, right? Println is an existing method or a constructor. So syntax difference you can see here. This is the syntax for method reference. This is the syntax for lambda expression. Use case when you want an inline expression. So when you already have a method that matches the function interface signature. So in the example we showed, println is an existing method that is kind of matching the signature. So it was basically replaced. And compared to method reference, this is less concise. This is more concise and readable. It can contain multiple statements, as I was already telling. It will only contain one statement of the existing method, cannot have extra logic. So I hope it's very clear to you. So method reference is useful only if it is possible to replace the lambda expression with some existing method. So if lambda is having multiple lines of logic, you can't go with method reference. Little more details of the method reference. So you have to understand the types of the method reference. So here you can see a static method like integer parse int. So this is a static method. This is how you can refer. So let's say if it is instance method, then you can use the object name and the instance method name here. Let's say you want to call an instance method of the arbitrary object. You can use this. This is almost same as first example. Third example is a constructor reference. So let's say you want to use constructor. Then I can specify like this. So this is more variations of the method reference. So this will be useful for our day-to-day coding also. If you have not used, please check out and understand more about it. So basically lambdas are more general and method reference are shorthand when you are already have a method with a correct signature. And both are interchangeable in most of the cases. Method reference improves readability and reduces boilerplate. I hope it's very clear to you. Let's move on to the next question. So
So
let's
let's
move
move
on to
on
the
to the
next
next question.
question. How
How
are
are
variables
variables
captured
captured
or
or
used
used
inside
inside
the
the
lambda
lambda
expression?
expression?
So the answer is lambda expression can capture the variables from the enclosing scope. Okay. However, only variables that are final and effectively final can be captured. So final you should be clear, right? Like a variable should have final keyword attached. So that can only be used. What is this effectively final means? So effectively final, I have taken an example here. You can see, right? Int x equals to 10 is there. So this is effectively final only if it is not changed anywhere after that. So let's say here we are changing x equals 20. This will break that behavior. So main difference between final and effectively final is both value can't be changed. So, but in case of effectively final, we will not have final keyword attached. That is the only difference. So the answer to the question is so lambdas can capture the variables which is enclosing scope. That's first thing. Second thing is it should be final or effectively final. Then only it is possible. So you can ask me a question why it should be final or effectively final. So why lambda should handle only final or effectively final variables? Mainly because of the thread safety. So here, if you see, right, if for example this X is changed here, what will happen is if two threads are executing, one thread is printing 10 here and it changes the value to 20, another thread will go and make it as 20 here. So another thread when it is executing, it will print value as 20. So that's one of the main reason why lambdas should handle only final and effectively final variable. I hope it's very clear to you. You should know this very well because it's one of the important interview question as well. Let's move on to the next question. Let's move on to the next question. The question is what is optional and why it is introduced. So basically optional is like a container object. It may or may not hold a non-null value. So what it means is you can store either null or non-null value within the optional. So it's part of util package. So instead of returning null, so we are returning optional. So the caller will check whether it is present, then only get it. So this is mainly introduced to avoid the null pointer exception. Because if the caller forgets to check for null, with optional, what will happen is they have to explicitly kind of check whether the value, if it is present, then only proceed for it. So that is kind of helpful during the stream operation as well, like with map, filter, or else if present everywhere, it is helpful. So the main intention of optional was to avoid the null pointer exception. So that's the answer. So optional is mainly introduced to avoid null pointer exceptions. So I hope it's very clear to you. Let's move on to the next question. So the next question is what is the difference between or else and or else get with optional? So basically or else it takes a value. It's an eager valuation. This argument is evaluated immediately whether the optional is empty or not. So I'll show you with an example also. So or else is an eager valuation, like it will not check whether the optional value is present or not. It will execute. But in case of or else get, so it takes a supply function interface. It's a lazy evaluation one. So it will only be executed if optional is empty. So let's see the example and understand better. So
So
here
here
I
I
have
have
created
created
an
an
optional
optional
string.
string.
So I'm
So I'm
just
just
printing
printing
that.
that.
So
So
here
here
I'm
I'm
showing
showing
an
an
example
example
of
of
dot
dot
off.
off.
As we
As we
know,
know,
with
with
off
off
null,
null,
it
it
will
will
throw
throw
an
an
exception.
exception.
And
And
off
off
nullable,
nullable,
as we
as we
discussed,
discussed,
it
it
can
can
hold
hold
null
null
values.
values.
And
And
optional
optional
empty
empty
is
is
to
to
return
return
an
an
empty
empty
optional.
optional.
So
So
here
here
we
we
were
were
discussing
discussing
or
or
else,
else,
optional
optional
off
off
dot
dot
or
or
else.
else.
So
So
even
even
if
if
this
this
is
is
empty
empty
or
or
not
not
empty,
empty,
this
this
will
will
always
always
be
be
called.
called.
But
But
in
in
case of
case of
or
or
else
else
dot
dot
get,
get,
it
it
will
will
be
be
called
called
only
only
when
when
this
this
is
is
empty.
empty.
The
The
first
first
option
option
is
is
empty.
empty.
So
So
let's
let's
try to
try to
run
run
and
and
see.
see.
So
So
we
we
should
should
see an
see an
exception
exception
first.
first.
After
After
that, we
that, we
have to
have to
commit
commit
that
that
to
to
proceed
proceed
to
to
the
the
next
next
lines.
lines.
So you
So you
can
can
see
see
we
we
got a
got a
null
null
pointer
pointer
exception
exception
at
at
line
line
about
about
10.
10.
So
So
because
because
optional
optional
dot
dot
off,
off,
if
if
we
you
are
are
using,
using,
we
we
should
should
be
be
sure
sure
it
it
should
should
be
be
non-null
non-null
value
value
only.
only.
So
So
I'll
I'll
just
just
commit
commit
this
this
and
and
run
run
the
the
remaining
remaining
ones.
ones.
So
So
here
here
we
we
are
are
printing
printing
hello
hello
first.
first.
So
So
second
second
is
is
word is
word is
printed.
printed.
So
So
here with
here with
optional of
optional of
nullable, we
nullable,
are
we are
passing
passing
null
null
and we are
and we are
checking
checking
if it
if
is
it is
present.
present.
If the
If the
value is
value is
present, it
present,
will
it will
return
return
true,
true,
otherwise it
otherwise
will
it will
return
return
false.
false.
Here we
Here
are
we are
having null
having null
value, so
value,
it
so
should
it should
return
return
false.
false.
So that's
So
what
that's
is
what is
printing
printing
here.
here.
And
And
next
next
is
is
optional
optional
empty.
empty.
So
So
same
same
thing,
thing,
no
no
value is
value is
there.
there.
We are
We are
getting
getting
again
again
false.
false.
So
So
this is
this
an
is an
interesting
interesting
piece,
piece.
as I
As I
was
was
telling.
telling,
So
so
this
this
one
one
Maybe I'll comment this line just for the demo purpose and I'll run it. So or else method, right? This will always be called, it will not check whether this first half is empty or not. So this is the main thing. So let me comment this guy and run it. So here you can see there is no call. So this get name is not called because this dot or else get is a lazy operation. It will first wait for this to be executed, whether it is empty or not. If it is empty, then only this will be executed. If it is non-empty, then this get default name here, the method call we are making as part of or else get is not executed. I hope it's very clear to you. So I hope you understood different functions of the optional and its differences also clearly. So main differences are argument types as we discussed. So we'll pass the direct value. Here there will be a supplier or lambda function will be called. And evaluation, it's an eager one, always executed. This is a lazy one. And performance wise, this is a bit expensive because it will always execute. This is efficient. And this is like if there are some default values, not much competition involved, this is fine. But let's say if there are some expensive calls are there, then this is the best one because it will wait for the first half to be executed. Only then this second half will be executed based on that, whether it has to. So basically it will decide whether or else get has to be executed or not based on the first half, whether the optional is present or not. So I hope you understood the difference. Let's move on to the next question. So the next question is what is the difference between optional dot off nullable and optional dot empty? So optional dot off basically it creates an optional containing non-null value. So if the value is null, it throws null pointer exception. Okay. Optional off nullable, as the name indicates, it can hold null value as well. So basically, if you want to store null value, it return optional empty. It's safe. It's safe when you're not sure whether the value is not null or null. So go for off nullable. Optional empty. So it's basically to create an empty optional, we'll go for it. It's almost equivalent to optional off nullable of null. So I hope it's very clear to you. We'll see examples for this in a while, but after the next question, we'll go for an example. I hope it's very clear to you. Let's move on to the next question. So the question is, how does HashMap handles collisions after Java 8? So before I explain this, we should understand what is collision here. So basically HashMap, right? I'll first explain till Java 8 what was happening and what has changed from Java 8. So basically what will happen is whenever you want to store an element in the hash map, internally first hash code will be calculated based on the key you are storing. Okay. So internally hash map contains a buckets and each it's an array of buckets. Okay. Each bucket will point to a linked list. So first what will happen is when you want to store, right? First it will check based on the hash code what is the location in the array of buckets. Let's say if it is 0 in the bucket. So 0 will point to one linked list. So first entry it will directly go and store it in the linked list. But so let's say if you want to store another entry in the hash map and let's say the hash code of that entry is also 0. So what will happen is first it will go and check the hash code and see the linked list. If there is already an entry present, then it will compare its keys. If it is same, then it will override the existing linked list entry. Otherwise, it will create a new node. So this is how it will be worked. So basically, every time there is a collision, this is called as collision. So if two keys with same hash key will create collisions, so the new entry will be added in the linked list corresponding to it till Java 8. So the problem is, so we normally say, right, hash maps get complexity is O of 1. It's not always. O of 1 is a best case complexity. Why? Because let's say you want to retrieve some value, right? First, you will get the hash code. From hash code, you will see the linked list. If there is already linked list formed, you have to traverse the whole linked list in worst case to get the value. So the complexity will be of n in the worst case till Java 8. But what has changed in Java 8? So what Java 8 has done is, instead of storing it in the linked list, if the size of the linked list is crossing 8, if there are 8 collisions happened for a bucket, then it will convert that into red black tree. So with the red black tree, the worst case complexity is reduced to O of log n from O of n. So this is the advantage. I hope you got it. In case of collision, if the length of the linked list is greater than 8, then the red black tree is created and the new records are added there. So complexity will become of log n. So this is the improvisation to handle the collision. Let's move on to the next question.
So thank you so much guys for watching our video. So I hope you got the complete benefit out of it. So we have covered all the top 50 plus Java 8 interview questions which are commonly asked in most of the interviews. So like and subscribe to our channel, share this with your friends, and watch our other videos for your interview preparation as well as your backend preparation. Thank you so much.